Hi guys, welcome to the third video of module 9, and here I'm going to give you the example of how a CNN architecture looks like and what kind of things it is made up of. So over here, apart from the dense layers, which are called as the fully connected layers by the way, we are also going to learn about the convolution layers and the pooling layers. Together, all of this is going to form the CNN architecture, and how this particular example is going to look like, let's look into that in this video. So here is the typical example of how a convolutional neural network looks like. It is consisting of convolution operation, pooling operation, and fully connected layers. It's not that you can just have only one convolution operation, one pooling operation. You can have multiple of them. And to be honest, if you are dealing with some specific type of data set that's focusing on something really very intense, you can also introduce some more layers, like let's say for example RNN, right? But all that kind of things are a little bit advanced. If you are looking forward to a very plain convolutional neural network, these are the layers that you should be aware about. The convolution layer, pooling layer, there is also a flattening layer that you can see over here. And after that, we are having a fully connected layer, right? So what is the whole idea of this CNN? We could also do the same kind of things that a convolutional neural network do with the help of any machine learning algorithm that we had seen earlier, and also from the neural network. Then what is the need of this convolutional neural networks? So just imagine if I tell you that each neuron is going to take one pixel, okay? If one neuron is going to take one pixel. And if I tell you that you are having an image with the size of 256 by 256 and there are 3 different channels to it. Just think about how many total pixels you are going to pass into the image. So if I do this calculation on my calc, it gives me 1,96,608 pixels. So this many input neurons is going to be there, and therefore you will be having more neurons to understand this kind of complex relationship between the input and the output. Let's say output is identifying if the image is having a horse or a not horse. So it's going to have a lot of model parameters, and therefore the computational efficiency is going to be just not good. And therefore, with the help of this convolutional neural network, we are trying to solve this problem, that by using this convolution operation and the max or any kind of pooling operation that we'll be seeing, you decrease the total number of pixels in an image. So once you get to the flattened layer, before that, the image will be very much dense in a way that it's going to have all the important features over there that you are converting into a 1D array. And now if you pass it to this neural network, like what we had seen in the previous module, then it's not going to consume a lot of model parameters, and therefore more efficient way while dealing with, let's say, image data or a video data. Right? I hope this is clear, that why do we need a convolutional neural network. This is one very important point that you need to know. Now, CNN is extracting features from the image to understand the patterns that is stored inside them. So this convolution operations and the pooling operations are going to help you understand what are the stuff present in an image. And these typical patterns are normally edges, different shapes, textures, objects, colors, etc. What is the exact idea of the convolution operation, pooling operation? Everything I'll be explaining it to you in the upcoming videos. But I hope a clear picture of what a CNN looks like is clear to you. So now that you are having a little bit of idea of how the CNN architecture looks like, in the next video, let's start by understanding the complete idea about the convolution operation. So I'll see you in that next video.